Okay, in the previous video we looked at defining entities and all of their associated properties. What I want to look at today, or in this video, are entities and the relationships between entities. So I'm not going to consider attributes at all. It's simply entities and how they're related to each other. And there's a fair bit of subtlety involved in defining these relationships. So you're capturing some relatively fine-grained semantic notions when you consider. So I'm just going to look at a system where we've got teachers or lecturers, courses, students, degrees and assignments, and see how all of these things are related. So I'm not going to draw a single big diagram, I'll just draw individual relationships. Okay, so the first one I want to look at is the fact that lecturers teach courses. So obviously the entities involved in that are lecturers and courses. Okay, so what about the relationship? Well, clearly from the diagram here you can see that relationships are done inside diamonds, and obviously the relationship is going to be something like teachers. Okay, so lecturers teach courses. Now, a given lecturer is likely to teach a number of courses, and a course, and here we're talking about, well, a course may have several lecturers. So this is a classical end-to-end relationship, and that's indicated simply by a pair of lines, unadorned lines between the relationship diamond and the entities. So lecturers teach courses. The next thing I wanted to look at was the fact that there are lecturers in charge. So each course has a single lecturer in charge. Well, the other thing I should have said about that too is that there may be lecturers who don't teach any courses, and there may be courses that don't yet have any lecturers. So we haven't put in a requirement that either lecturers or courses be involved in that relationship. Okay, the next relationship, lecturer in charge, changes that a little bit, and I'll just write that as LIC, lecturer in charge. In this case, every course has to be assigned a lecturer in charge. So that's total participation of that entity in that relationship. Every course's entity has to be involved in this relationship. We indicate that either by a thick line or by doubling up the the line. The other aspect of the semantics of this is that every course must have exactly one lecturer in charge, and the notation that we're using, and there are variants of the notation in the literature, but the one we'll use in this course is to put an arrow there. So that's kind of meant to be a functional type notation. So courses map to a single lecturer is the way to read that. So that captures a lot of fine-grained details about this relationship between these two entities. Every course has exactly one lecturer. Okay, the next item on the agenda is assignments. So I'll do a separate diagram for that. And I'll write courses again just so it makes the diagram a little bit neater. So we've got courses and assignments. Now, we don't reuse assignments in courses, because if we do, students tend to just get solutions from the last time the course was run. So in this case, we want to have assignments are related to courses by being used in courses. So our relationship can be used in. There may be assignments that are floating around that haven't yet been used in courses, so we won't force every assignment to be used, but probably eventually they all will be. The other aspect of this relationship, what I said before, was that each assignment is only used in one course. So once again, we have this 1 to n relationship, which we indicate like this. So each assignment is used in exactly one course. The fact that we don't have an arrow here means that a particular course may have several assignments used in it. And I didn't mention up here, the fact that there's no arrow here means that a given lecturer could be the lecturer in charge of several different courses, but each course will only have one lecturer in charge. And if you remember back to the original requirements, the fact about assignments and courses are actually specified by 2 bullet points. This relationship here was specified by a single bullet point. Right, next we've got students and degrees. So each student is enrolled in a degree. Now, each student is going to be enrolled in one degree at a time, but it's quite likely that over the course of their lifetime, especially these days, students seem to take more than one degree. So, in fact, this is going to be an end-to-end relationship. If you're a student, you ought to be taking at least one degree. So we can insist that students, all students participate in this relationship. We're not going to insist that degrees are taken. Maybe we have new degrees that haven't yet been offered, so they won't have any students enrolled in them. So that would be a representation for that scenario. So students and degrees. And the final thing I wanted to look at, and I think I will try to erase this, and that's pretty well done. Okay, so students, I guess I'll leave the total participation, although technically it's probably not necessary. But students enroll in courses. Okay, so a student may enroll in several courses, obviously, to complete a degree, and generally a course will have more than one student in it. So that's going to be an end-to-end relationship as well. Now, if we go back to the requirements, it says that a student has a mark and a grade for each course. Now, I guess potentially we could associate students to courses with a grade or something like that, but in fact, that piece of information is more of an attribute-like thing, and the attribute is associated with the fact that a student is enrolled in a particular course. So it's not an attribute that's attached to an entity, it's actually an attribute that's attached to the relationship. So a student enrolls in a course, and for that course they get a mark and they get a grade. Okay, so attributes aren't necessarily just associated with entities. Quite frequently we use them to capture properties of the relationship between two pairs of entities. Okay, so that's a rundown of all of the different kinds of relationships. So as you can see, you can capture fairly subtle semantics of the connection between pairs of entities. So using that, you can capture the fine details of the semantics of the problem when it comes to doing database modeling.